let me assume that you are familiar with the sum identity and difference identity, and I'll go over an example how you use this identity to find all the trigger functions value at a different angles than 30, 60, or 45, or multiples of those angles. So here is, I put an example of find the exact value of cosine 15 degree. Now you must know cosine 15 degree, especially 15 degree, is a special angle 45 degree minus 30 degree. Or you could use 60 degree minus 45 degree, either works, which is same as a cosine 15 degree. So if you're trying to find a cosine 15 degree, you want to use difference identity using a given angle, something familiar angle like 45 or 60 or 30. So here I chose 45 degree and a 30 degree. Cosine difference angle identity is cosine x minus y, and it is cosine x, which means cosine 45, cosine for 30 degree, cosine, you see, cosine x cosine y plus sine x sine y, and x is 45, y is 30 degree. So cosine 45 degree, cosine 30 degree, plus sine 45 degree and sine 30 degree according to that difference identity. So to find exact value of cosine 15 degree, I'm using a difference identity. Now you know cosine 45 is square root 2 over 2. I hope you do. So that's that. Cosine 30 degree is square root 3 over 2. And sine 45 degree is same as cosine 45 square root 2 over 2. Sine 30 degree is 1 over 2. Now it's just a matter of multiplying fractions. So square root 2 times square root 3 is square root 6 over 4. And square root 2 times square root 1 is square root 2 over 4. Since you already have a common denominator, you may write it square root 6 plus square root 2 all over 4. And you cannot add the square root 6 and square root 2. So you will leave the answer as it is. And this one is equal to the exact value of cosine 15 degree. Now let me go to next example. Find the exact value of sine x plus y, and sine x is given to you as a 3 over 5, cosine y is given to you as a 4 over 5. X, the angle, don't forget x is not the x coordinate. Here x is representing an angle in first quadrant. Y is representing an angle that's in the fourth quadrant. So if this is given to you by the sum identity sine x plus y, sum identity is sine x, cosine y, plus with plus, cosine x, and sine y. And there is a sum identity. Make sure you memorize the correct sum identity. So sine x and cosine y is given to you, yet you don't know what cosine x is or sine y is. So that's why we have to find it using this given value. So here I will actually draw the angle x, which is in the quadrant 1. So x angle is right here. Sine is opposite over hypotenuse. So that means 3 is here and 5 hypotenuse right here. So that will be sine x equal 3 over 5 give you this right triangle, 3 over 5. Make sure your vertical leg goes down to x-axis always. And now that means this horizontal leg of the right triangle is square root of 25 minus 9, which is square root of 16, and which means horizontal leg is 4, which means cosine x is adjacent over hypotenuse. So 4 over 5 will be cosine x. And now in the same information, I have a cosine y equal 4 over 5. But here y is in quadrant 4, so I will have to draw the right triangle on quadrant 4. In quadrant 4, you will have to draw y is this angle or something coterminal to it. Why is that? And when it comes to cosine, its adjacent is 4 and hypotenuse is 5. That means the vertical leg, make sure you draw the vertical leg toward the x-axis, and the vertical leg is your y, and that the vertical leg value should be negative value since you're in quadrant 4. So it's a negative square root of 25 minus 16 by Pythagorean theorem. So that's a 25 minus 16 is square root 9, which means it's a negative 3. Since cosine y is 4 over 5, sine y must be now negative 3 over 5, opposite of hypotenuse. Now I'm just multiplying, substituting all the numbers. Sine x is given to you as a 3 over 5. Cosine y is given to you as a 4 over 5. You're multiplying two fractions. And cosine x we found to be positive 4 over 5. Sine y we found to be negative 3 over 5. What we get is 12 over 25, 12 over 25 minus 12 over 25. Also, it's exactly the same number subtracted, so answer is 0. And that's one example. Tangent. So this is one example is a tangent sum identity. Because 75, tangent 75 is, I want to get an exact value. Tangent 75 is 30 plus 45. The reason I chose 30 and 45 because those are special angles. You know already what tangent 30-degree value is, and you know already what tangent 45 is. So that's a sum identity of tangent 30-degree plus 45-degree. And according to sum identity of tangent, you would go like this. Tangent 30-degree plus tangent 45-degree over 1 minus tangent 30-degree multiplied by tangent 45-degree. If you don't remember this, let me go and check. You go back to sum identity. Tangent x plus y equals tangent x plus tangent y all over 1 minus tangent x times tangent y. So I'm using the sum identity over here. And so tangent 30 is square root 3 over 3. I hope you know that. And tangent 45 is 1. And 1 minus tangent 30 is square root 3 over 3 multiplied by 1. And so what you're getting is square root 3 over 3 plus 1 over 1 minus square root 3 over 3. And so this one is a complex fraction because we have fraction over fraction. When you have a complex fraction, you want to multiply by common denominator. So common denominator is 3, so I'll multiply by 3 to each fraction. So 3 times here, 3 times here, 3 times here, and 3 times here. That get rid of the denominators. And so you will get square root 3 plus 3, and on the bottom 3 minus square root 3. Now this is still radical in the denominator. We need to rationalize that. So when it comes to rationalization, you need to multiply conjugate of the denominator. What is the conjugate? It's a minus b. So you have to multiply a plus b, top and the bottom. A plus b, top and the bottom. And now a plus b denominator is a minus b times a plus b. So 3 to the square minus square root of 3 to the square, which is 3. And that's denominator. Numerator, you will have to distribute it. So 3 square root of 3. Square root of 3 times square root of 3, which is 3. 3 times 3 is 9. And 3 times square root of 3 is 3 square root of 3. And now you can add 3 and 9, which is 12. 3 square root of 3 plus 3 square root of 3 is 6 square root of 3. And denominator 9 minus 3, which is 6. Now you notice that there is a 6 common factor in the numerator. So I'm factoring 6 out, and you would have that. And 6 times 1. So I can cancel 6 over 6, which is 1. And what's left is just the numerator all over denominator. When denominator is 1, you don't write it. So answer is this one. That is your tangent 75 degree using the sum identity, and it's called the exact value of tangent 75 degree.